Earthquakes. They're one of the planet's most destructive natural disasters. Engineers aspire to find solutions so that buildings can withstand Mother Nature's most powerful punches. And as our global population moves closer to the ocean every year, tsunamis, caused by earthquakes, create an extreme hazard for our society. At Oregon State University, engineers and students are recreating the ocean's natural forces on coastal environments. Welcome to the world's largest tsunami wave basin. One of the main attractions is a 300-foot-long flume.
If you just walk into the lab, it looks like just water hitting an orange box, no big deal. But the flume is a simplification of nature. You know, in real life you have wind, tide, all these other variables, but there's a lot that goes into the scaling, so the dimensions of the box, how big the waves are, what the water depth. So we put a lot of sensors in the tank and around the box, and it allows us to figure out whether or not that structure would survive the big disaster.
It's amazing to think that these wave boards can generate 15 tons of water force within 3 seconds.
It's similar to a truck running into the front door. I mean, it's just a phenomenal force by the waves on these structures. So what we're hoping to get in general from these tests is a new way to think about building on the coast, coming up with safer designs, better designs that allow us not to give up on the coast, but really enjoy the coast and have a lot less risk to the people and the infrastructure that's on our coast.
At the University of California, San Diego, earthquake engineers like Tara Hutchinson are working to protect human life by building tough structures.
It's our obligation as engineers and scientists to build and design structures that remain resilient following an earthquake.
What is Tara's main tool for studying earthquakes? The world's largest outdoor shake table.
It's as if we're making an appointment with an earthquake.
Tara and her team are able to control and accurately measure the forces imposed on this full-scale, 6-story structure.
We placed about 250 analog sensors throughout the building. We also placed digital video cameras throughout the test building so we could monitor the main structural components and the local connections. These are things we don't see when a real earthquake occurs.
Drones are also deployed to gather rich data sets before, during, and after a test quake. Once all the data gathering tools are in place, it's time to see if this cold-formed steel can withstand a significant earthquake. Once the tests are completed, Tara and her team transfer the billions of data points to a state-of-the-art visual analytics lab. This wide-angle virtual environment, known as WAVE, is an ultra-high-resolution immersive 3D interactive display.
The data coming from those measurements is going to be critical to advancing building design codes in the future. Design engineers need a scientific basis for producing buildings that are going to perform well during future earthquakes.
The new building codes that will come out of the work being done at OSU's WAVE Research Lab and UCSD's Shake Table facility will save countless human lives and billions of dollars in rebuilding damaged infrastructure. Building a more resilient society. This is the goal of engineers. And when engineers dream big, the impossible becomes possible.